So we can say that the limit is a y value as x approaches some x value. The limits of y value, the limits of y value. X is in control. It's like my feet's in control, right? It's where my body's going to end up. That's the y value. It really is going to be a coordinate point on a graph. Our notation is going to be this. And this says the limit as x approaches c of f of x equals L. L is a y value. So LIM is the limit as x approaches c of f of x equals L. L is a y value. At some x value. So if I have a nice looking graph, right, it's just the y value. So if I kind of go back to this guy, it's just the y value at that x value. That's what the limit is. So that says if I plug in x equal 1 into my original function, I'm going to get y equal 2. That's where they end up. They end up at that dot on the graph. Same thing is true here. It is the y value that if that open dot wasn't there, it's the y value at the whole. As though there was a solid dot there instead of an open dot. Why? Because they don't get there, they're just close enough to call it. But it says if they actually got there, could get there, where would they be? They would be at that y value. So that's how high off the ground they would be. So here we go. So if I'm going to calculate a limit by hand, it is the y value at that x value. So that says I want to find the limit as x approaches 1 of 2x squared plus 3x minus 3. And it says show that it is equal to negative 2. So we saw that graphically. Algebraically, all I'm going to do is I'm going to let x be equal to 1 and plug it in. So that would say that if I take the limit as x approaches 1 of 2x squared plus 3x minus 3, it would be equal to, so the first thing I do is, it's the y value at some x value, plug it in, and see what I get. 2 times 1 squared plus 3 times 1 minus 3, which is 2 plus 3 minus 3, it's 2. It's the y value at that x value. The fact that I got a number means I'm done. That is the limit. It is the y value at that x value. Yeah. Well, we'll see. That's where life gets more interesting. Now, we also saw on the previous page that the limit of this guy was 2. That was where you have a hole in the graph. Well, what am I going to do? Well, the first thing I do is I let x equal 1 and I plug it in. So that would mean that the limit as x approaches 1 of x squared plus 2x minus 3 over x squared minus 1 is 1 squared plus 2 times 1 minus 3 over 1 squared minus 1 is 0 over 0. Now this is an indeterminate form. And what did I say an indeterminate form screams? Algebra. What this says is, I don't know what the dang limit is. I need more info. You need to do something to make this work. Well, in this particular instance, since I've got a 0 over 0, what does that mean? This means that x equal 1 is a 0 of both the numerator and denominator. Or x minus 1 is a factor. Welcome back to college algebra. So what this means is I need to factor and reduce and try again. See what happens if you don't get a number? You get 0 over 0. That means I need to do some algebra on it. So then what does this become? Well, I look at x, x minus 1, x plus 3 over x minus 1, x plus 1. X minus 1's reduce out, so I'm left with x plus 3 over x minus 1. The stipulation is x can't be 1. And you say, well, why not? Because I have removed the problem. So now I look at the limit as x approaches 1 of x plus 3 over x minus 1, and just plug it in, plug it in. What it's going to give me is the y value at the whole. Yes?
Why is it x minus 1 and not x plus 1?
Oh, it should be x plus 1, thank you. Otherwise I'm in trouble, right? Because I'd have one, and I'd be back where I started. So this is, what is it? It's 1 plus 3 over 1 plus 1, which is 4 over 2, or 2. It's the y value at the whole. I took the problem out, so I didn't have a division by 0 anymore. So what I now was able to calculate out is what is the y value at that whole. And it is 2. So we can say that the limit is a y value at the desired x value, and then I have to put the words, if it exists. And we're going to be talking about existence and non-existence.